Hey guys, Claire's here. Do you want to say hi, Claire?
No.
My daughter Claire. So if you hear any weird noises, that's probably her. Um, so, I wanted to go through these periodic trend notes and the worksheet. It should be pretty simple. On Wednesday, I'll post something else about ionic bonds. So, Claire. So that'll be coming up. Some of you already turned it in. So, if we go to the let me go back. Go to the week 4 learning periodic table trends notes, and your worksheet is over here. Okay, so I'm just going to run through the notes with you, and then if I have time, I'll do a little bit with the worksheet. So, this is kind of a cool picture of vitamin C, how it's bonded together. So we're going to be talking about chemical bonds, how compounds are made from atoms. Some of this you've done before, so I'm hoping it won't be as hard as our electron configuration. So we're going to look at some different trends in the periodic table, but before we do that, I want to remind you, because this is going to be important later on, that all of these green boxed, everything to the left of the stair step, are metals. The purples are our nonmetals, and hydrogen is our exception. And then these pink ones, orange, whatever color that is, are the metalloids. Okay? So one of our trends is that our metallic characters increase from right to left and from top to bottom. So as we move from right to left, they're going to become, that doesn't seem right, they're going to become less metallic. Okay? And then as you move from top to bottom, they become more metallic. Okay, so this is going to be our most metallic element. I'll change that in the notes for you. It should be it decreases from right to, increases from right to left. Yeah, so going this way. All right, our atomic radii are the sizes of the atoms. So as we increase the number of energy levels, it's going to get bigger. So as we move down a group, the size of our atoms increases. Within that energy level, they actually decrease, which is kind of interesting. But as we move to the right on the periodic table, we're adding positives, which is pulling those electrons closer and makes the atoms a little bit smaller as you move to the right. The ionization energy is how much energy it takes to remove an electron from a gaseous atom. And these are set, so people have experimentally determined what the ionization energies of different atoms are. And the group A elements, so those alkali metals, increases from the bottom to the top. So it's lowest on the bottom, highest on the top. And then it increases from left to right. So as we're moving to the right, it takes more energy to remove an electron. Helium is going to be have our highest ionization energy because it's the furthest to the right and the furthest up. And that makes sense because we're not going to be able to remove electrons easily from our noble gases, right? They're pretty unreactive. Okay, this just shows in each group that it's going up as you move towards the noble gases. It takes more energy to lose an electron. Okay, again, these are our experimental. The first, second, third, fourth, fifth, that's losing the amount of energy to lose the first electron, a second, third, fourth, and fifth. And as you lose more and more electrons, of course, it's going to take more energy. Our nonmetals have relatively high ionization energies. Okay, they take a lot of energy because usually they gain electrons, if you think back, to be stable. They form negatively charged ions, so our our halogens, our group 17, are going to form negatively charged ions. Our highest ionization energy is going to be fluorine besides our noble gases. Okay, so which elements have the highest ionization energies? Are halogens, alkali metals, noble gases, alkaline earth metals. You guys, what do you think? Oops. If you said noble gases, you were correct. Okay, they have the highest energy to lose an electron. Metals generally form ions by what? Gaining electrons and forming positive ions, losing electrons, forming positive ions, gaining electrons, forming negative ions, losing electrons, or forming negative ions. What do you guys think? So metals are going to be positive, so we can already eliminate C and D. But do they lose or gain electrons? Well, to become positive, they're going to lose electrons, right? Electrons are negatively charged. Okay, so the answer here is B. Alright, that's it for today for the notes. If you guys go back into the classwork, your periodic trends worksheet, there's some vocabulary. Some of them were in the notes, but not, well, really just one of them was in the notes. So don't worry too much that you can't find those in the notes. You can Google them, you can look them up in the book if you want to. Okay, it's chapter 11. The part 2 is using your book and notes. You're going to rank by radius, okay, by increasing electronegativity, ionization energy. Okay, you're going to just go through these. I forgot to tell you this too. I'm going to go back to a periodic table here. We talked a little bit about valence electrons. Valence electrons are in that outermost electron shell. So if you remember Bohr's model with all of the different circles, the outermost circle is going to be whatever your valence electrons are. And they are important because they are the ones that do the reacting. Okay? So your group 1, these, your alkali metals are going to react similarly because they all have one valence electron. Group 2 has 2. We skip the transition metals because they're different. Group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8, except for helium, which has 2. Okay, so it goes 1 valence electron, 2, skip the transition metals, 3, 4, 5, 6, 7, and 8. And if you have a periodic table and you want to write that on there, that would be fine. And again, these all react similarly because they all have the same number of valence electrons in each group. Okay, your alkali metals act similarly because they all have 1. Your alkaline earth metals have 2, so they react in similar ways, and so forth. Alright, please let me know if you have any questions, and hopefully I will see you soon. Bye.